Good afternoon and welcome to the live broadcast of the launch of the first ever fully stacked Gryphon rocket from LC-01 at Base Alpha in the Uthain Republic. I'm Chris, an ALS engine technician, and I'll be guiding you through today's flight test. If all goes according to plan, then we will see Gryphon complete a roughly 40-minute suborbital flight, focused on demonstrating the performance of the first stage and orbital capability of the second stage. This flight is essential for proving our architecture and gaining experimental data on the vehicle's performance as we work to prepare Gryphon for commercial operations in 2027 involving missions to Luna, Silero, Tydos, and beyond. Gryphon is a two-stage rocket powered by the next-generation ALS engine. It runs on liquid oxygen and liquid methane, and it has been designed for as low as 20 missions. We're using a lot of lessons learned from the engines flown on Fusion 2 in order to get this engine to be as reliable as possible. But we can only dial in the engine properly from a test such as today's. The first stage is fitted with 25 of those engines, 9 of which have gimbal capability. It's also worth noting that the outer engines run at a lower thrust level, but this is something we're looking to change in the future. The second stage is fitted with 6 of the engines in a little bit of a unique configuration. Unlike traditional upper stages, Gryphon does not utilize a vacuum-optimized engine. We're sacrificing some efficiency to simplify the manufacturing process, which is an absolute must for a rocket of this scale. And here you can see a video of one of these engines going through acceptance testing at our test facility in the Uthain Republic. It's going to be exciting to see all 25 of these engines in action today. As mentioned earlier, Gryphon will be the largest rocket ever after it lifts off. It stands at 116 meters in height, and it has a dry mass of approximately 400 tons, and, fun fact, the upper stage heat shield alone weighs about 10 tons. Gryphon's upper stage is a really special vehicle, as it's designed not only for reuse, but for powered landings on other planets/moons. It has a large volume of propellant in tanks, which are isolated from the main propellant tanks during ascent. These will be used to feed the engines during landing burns and on orbit operations. As you may have seen, there are 2 little flaps at the base of the upper stage. They will be used to stabilize the glide path of the vehicle as it re-enters the atmosphere at speeds of up to 12,000 kilometers per hour or Mach 10. With such a high velocity during entry, the spacecraft will get very hot, and so to protect the vehicle, we have covered over half of it in square thermal protection tiles. There are over 16,000 of these held in place by pins and adhesives, and they should be able to handle the harsh temperatures, which we expect to be in the region of 2,150 degrees Celsius, or 3,905 degrees Fahrenheit, or 2,423 Kelvin. We have actually tested Gryphon's upper stage previously. Back in 2024, we conducted several tests, including 3 flights, 2 of which were to high altitude. Although their landing profiles aren't representative of what we'll be using on flights going forward, it was crucial to gain some experience of how the vehicle responded to the stresses it will see during its operations. The campaign was high risk and high reward, with one of these flights successfully making a soft splashdown in the ocean off the coast of the National Space Center. Since then, we've implemented several hardware redesigns and flight profile upgrades, which are better optimized for vehicle performance. One thing that certainly stands out on Gryphon is its lack of landing legs. This is by design, and not because we're splashing down in the ocean today. Gryphon is planning to use a new method of landing, which will lower the vehicle's dry mass. And that approach is to simply catch the vehicle in the air with the very same arms we used to stack the vehicle. It might sound dangerous, but the software for this has already been flown and tested on Fusion 2 back in April of this year. Those first catch attempts could happen as early as the second flight if we can make a good splashdown today. Another benefit of this approach is that it will enable faster recovery of the vehicles after launch. Rather than taking 48 hours to safe the vehicle and get back to the hangar like Fusion 2, we can safe the vehicle and put it right back on the launch pad in less than 2. It's going to be so exciting to see.
Ship propellant load complete. Booster propellant load complete.
We are now under 4 minutes away from Gryphon's first launch. Propellant loading has been completed on the first and second stages. Teams will now begin the process of clearing out the fluid lines at the launch pad. At the 2-minute mark, we'll begin pressurizing the tanks and storable gas containers on the vehicle to their operational levels. If we need to, there is an optional hold gate at the 30-second mark. However, everything is looking great for an on-time liftoff this afternoon, and we're not expecting any holdups. Just a reminder that today's flight is not an operational mission, but a test of the first Gryphon rocket. Just like our earlier test campaigns, it is high risk, high reward. There are no expectations that this will be a flawless mission, and we have closed down areas where this vehicle is expected to fly over today. If something does go wrong today, we will work in cooperation with CASA to ensure the reliability of the vehicle is improved for future missions. We're pushing the boundaries, but we make no exceptions for public safety. And with that, we will let you enjoy some of the ambiance and mission control callouts as we get closer to flight. I'll return shortly after liftoff to guide you through the events taking place.
Vehicle tanks are pressurizing. CASA exclusion zones are green. Test license is in operation. Tank press is complete. This is FD on Countdown Net. We are go for launch. T minus 30 seconds. T minus 15 seconds. T minus 10, 9, 8, 7, 6, ignition, 5, 4, 3, 2, 1. We have liftoff. Good Fusion 4. Good Gryphon. Stage separation. Ship engine ignition.
Boost back startup. Boost back shutdown.
It looks like we saw the start of that boost back burn, but it does appear that we've had an early shutdown. This is okay. The vehicle will still land within the exclusion zone. And more importantly, our second stage is on its way to space with all 6 engines. In a few seconds, we'll transition down to 3 engines, as we don't need the thrust of all the engines today. If you're just tuning in, we had a successful liftoff of Gryphon from LC-01 right at the top of our window, and we had an off-nominal boost back burn on the first stage. We're waiting for some status updates on the second stage, but it does appear that we've had an early end to our ascent burn and a loss of control.
Ship FTS is safed.
So you can see the booster making its descent through the atmosphere. We may try a landing burn, but this is an off-nominal flight path. The ship will not be performing the rest of its objectives today, and we're considering it lost. However, we'll keep the cameras running right until we lose the signal.
Booster landing burn.
So, as you can see, the booster's journey has ended today. We didn't expect it to perform that landing burn, but congratulations to the team for getting it this far. We can still see the ship tumbling around. We are expecting it to break up once it re-enters the atmosphere. We can see some plasma starting to build up on the second stage, while it is essentially falling down like a brick. This is a pretty incredible view. And I believe we have just lost the feed. Unfortunately, that will likely conclude today's flight. So much work was needed to get to the pad today, and we saw that successful liftoff with all 25 engines. If you want to stay up to date with the investigation into today's mission, then you can follow us on our social media accounts. Stay tuned for our next launch, which is already on the pad. We'll be conducting an in-flight abort test of our crewed spaceflight capsule. That'll be really exciting to watch. Congratulations to the teams here at Base Alpha for getting their first launch. We're very excited to see what happens next in the Gryphon program. We hope you enjoyed the ride, and we hope you have a great remainder of your day. Goodbye.